Let's see binomial random variable. So a binomial random variable, you can think of it as if it is a collection of all or many Bernoulli random variables. Earlier we have seen the Bernoulli random variable, right? Binomial variable is actually a combination of Bernoulli variables, right? So since there is a very little difference between them, that is why people don't really give much weightage to Bernoulli random variables. Even in GATE, they didn't mention in the syllabus Bernoulli random variable. Actually, there is nothing to talk about it. That is why they didn't mention in the syllabus. But about binomial random variables, there will be some questions possible on that. So one way to think about binomial random variable is it is a collection of Bernoulli experiments. Okay, to put in other simple words, just think about it. Let's say we are having an experiment. In that experiment, we are going to flip a coin. If you get a head, it is a let's say it is a success, and if you get a tail, let's say it is a failure. And assume that we are taking n coins and we are going to flip them, n coins. Then each of them can result in a success or each of them can result in a failure. Then if we count the number of successes using a random variable, then that random variable is called as binomial random variable. Are you getting this? Let us say we are flipping n coins, and when we flip a coin, head is a success and tail is a failure. And if we are flipping n coins, out of these n coins, some of them may come up as successes and some of them may come up as failures. And if you count the number of successes using a random variable, that random variable is called as binomial random variable. Got it? Let us assume that we are flipping 4 coins, and the probability of getting a head is 1 by 2 and the probability of getting a tail is 1 by 2. Assume that this particular probability is success, getting a head is success and getting a tail is a failure, and you are flipping 4 coins in total. Then what is the probability that you get exactly one success, right? So what is the probability that you get exactly one success? If that is asked, how can you answer it? See this. So exactly one success means out of these 4 coins you should get exactly one head. So that one head can be first one, or that one head can be second one, which means, or that one head can be third one, or that one head can be fourth one, right? So if you add all these cases, the probability of all these cases, then we'll get the probability of that getting exactly one success. How to do that? See this. If you see any of these cases, all these cases will have same number of successes and same number of failures. Therefore, if probability of head is p and if probability of tail is 1 minus p, all of them individually are going to have probability of p into 1 minus p cube, right? Here it is p multiplied with 1 minus p into 1 minus p into 1 minus p. Here it is 1 minus p into p into 1 minus p into 1 minus p. Here it is 1 minus p into 1 minus p into p into 1 minus p. Anyway, it is going to be p into 1 minus p power this one, right? And how many such events we have? That is nothing but how many ways you can arrange them, right? So we know that since it is a repetition, right, we can know the arrangements. So it is what is the arrangements here? You can see it is 4c1 or 4c3 you will get. Okay, so 4 factorial by 3 factorial, that is what you get. So total number of arrangements, total number of items is 4, therefore 4 factorial divided by repetitions are 3 factorial, which is nothing but 4c1. Got it? So this is how we can find out. And since here we are counting the number of successes, so what is this exact probability? The probability that number of successes equal to 1, equal to this, right? Similarly, if you want to count the number of p of x equal to 2, which means if you want to count the events that the number of successes is equal to exactly 2, then it is nothing but how many ways we can get 2 heads and 2 tails, right? So again that we can do with, if you have to have 2 heads, it is going to be p square. If you have to have 2 tails, it is going to be 1 minus p square, right? And then these 2 heads and 2 tails have to be arranged. We know that totally there are four values, that is why 4 factorial divided by 2 heads and 2 tails are repeated, 2 factorial into 2 factorial, which will turn out to be 4c2 into p power 2 into 1 minus p power n minus 2, right? So this is what is called as Bernoulli random variable. So again, simply put, what is Bernoulli random variable? If you are going to conduct n experiments, and every experiment there can be either a success or failure independently, which means every experiment individually taken is going to be Bernoulli experiment. Now we are combining all these n experiments, right? And now when we perform them, then if we try to count the number of successes we might get out using a random variable, that is called as Bernoulli random variable. Got it? So see this one. Suppose n independent experiments, each of which results in a success with probability p and a failure with probability 1 minus p. So which is nothing but Bernoulli event, each one, isn't it? So it need not be just a flipping of a coin, it can even be rolling a dice, but you have to define clearly what is success and what is failure. You might define that success is getting 1 and failure is getting any other number other than 1, or success is getting an even number and failure is getting an odd number. Whatever it is, you should be able to divide the sample space into 2 parts, that one part is going to be success, another part is going to be failure. Then you should find out what is the probability of success and what is the probability of failure. Of course, if you add both of them, it is going to be 1, right? So once you have such an event, then if you combine experiment and if you combine n such experiments, and then after performing all these n experiments together, if you try to count the number of successes, see this, are to be performed if capital X represents the number of successes that occur in n trials, right? So you are conducting the experiment 10 times and you are actually counting how many times you get the success. Then capital X is called binomial random variable with parameters n and p, which means if you want to talk about a binomial random variable, you should give 2 values. How many times are you conducting the experiment, which is n, and what is the probability of the success in each experiment, which is p. If you can give these 2 parameters, you can talk about that variable. Now the probability mass function of the binomial random variable, that probability mass function is nothing but the probability function, right, for a discrete random variable. Again, this is a discrete random variable, isn't it? This is clearly a discrete random variable because we are going to have some fixed values. If you are going to toss let's say 4 coins, the success can be 0 or 1 or 2 or 3 or 4, isn't it? Which means you have finite values and these are all discrete values, right? That is why it is a discrete random variable. Then the probability mass function is given by p of I equal to nci into p power I into 1 minus p power n minus I. nci means you know that n factorial divided by n minus I factorial into I factorial. You please look at the combinatorics videos, you will understand this better. Are you getting this? nci means n factorial divided by n minus I factorial into I factorial, right? So that is what just we have explained here. So p of I is nothing but what is the probability of getting I successes, that is nothing but nci into p power I, because successes have to be I times, isn't it? That is why we are taking p power I. And what is 1 minus p? It is failure. So out of n trials, if I are successes, then n minus I are going to be failures. That is why nci into p power I into 1 minus p power n minus I, right? So also we can prove that if you take all these probabilities and if you add them up, it is going to be 1. Why? See this. If you are conducting n experiments, then how many successes will be there? Successes will be either 0 or 1 or 2 or so on n. Now you add them all. nci into p power I into 1 minus p power n minus I. So which is nothing but this is a formula in the binomial expansion. If you remember that, a plus b power n, right? Then each term is nothing but like this, isn't it? Where a is this and b is this. Therefore, you can think of it as p plus 1 minus p power n, which is nothing but 1 power n, which is equal to 1, right? Which means sum of all probabilities is again going to be 1. Got it? We shall see some problems on this, you'll understand it better.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.